In this video, we look at section 2.10, which is basically a section that I'm going to call linear regression. And the essence of linear regression is based on the idea that we can see down here we have some data points. Okay, and there's two other data points given there. The first two data points, we have a fall enrollment in a course in a college. We can see that in the year, this point right here is in the year 1998, there were evidently 185 students enrolled. And then we have this point right here, that in the year 1999, there were 173 students enrolled. Okay, so one thing I want to to bring back into play is this concept of the average rate of change. And if we look at the average rate of change from the year 1998 to the year 1999, we can see that the average rate of change is going to be 173 minus 185. That's the change in the number of students, right, over a change in time of, let me see, 173, that was the year 1999 to the year 1998. Okay, so we can see that the slope of this line right here, there's a line connecting those, that we know that the interpretation of the average rate of change is the slope of that line, and that would be 173 to 185. That would be 7 minus 12 over a change in 1 year. So that was negative 12 students per year. Okay, so over the 1998 to 1999 year, looks like 12 students lost 12 students to enrollment that year. Okay, but there is a little bit of hope in this data. We can see that there is another time frame from the average rate of change from the year t is equal to 1999 to the year 2000, right? And we can see that there is a data point right here of the year 2000, and I'm getting this from the data that they're giving us in the problem, 178. So there's an average rate of change of 178 to 173. That's the change in the number of students. 178, that happened in the year 2000 and then the year 1999. And we can see that the slope of that line in blue is, according to the picture, going to be a different value than negative 12. We can see that the slope of this line right here, is positive. So we should get a positive slope, a positive average rate of change. And looks like that's 5 students in that year. So we've represented a gain in that year. So the fact that we are seeing two different average rates of change is basically saying that this data that we're seeing on the screen, this data is not linear. Okay, the data given is not linear because the average rate of change was not constant, right? But we can see in this problem that if we're willing to give up, the concept of being exactly linear, these points do not lie on exactly one line. But if we allow for the idea that maybe there is a line, we can see a trend, right? But we do, however, see a trend that the trend that the data is linear in its trend, right? We can kind of see that the data is heading kind of downward. So if we're willing to allow for a line that doesn't go exactly through all the data, but instead we would like to find a line that tries to best fit the data, then this data, we can say, can be represented as a linear function. So linear regression is this idea of us finding a best fit line, a best fit. And by fit, I mean it might not be exact, but it's going to be the best fit that we can make it. Okay, so the question is, how does one come up with a line that might best fit this data? And there's a lot I could say on this problem, but we should instead just focus on how technology might help us find the answer. All right, so I had the Desmos calculator up here on the side, and that was basically just a way for us to compute these average rates of change. All right, so there's the 178 minus 173, divide all that by 1, and so you could use the calculator to help you find these average rates of change. The problem is that this number you're going to get 5, in the case of 5 students per year, is only the rate of change on the blue section. These slopes are going to change. So what we want to do when we do a best fit line is to come up with a line of a single slope that will hopefully best fit this data. Okay, so that's what we're going to do now. Let me bring on to the screen. Let me bring on, give me 1 second if you don't mind. I will bring on to the screen our Google Sheets. Okay, and you can see that I have here the data already typed in that was given to us in the problem. Okay, so here we have the time in years and N being the number of students. And in a previous video, I've shown how to create a scatter plot of this data. So let me expand this a little bit. Here's just the data itself. Okay, and if you insert a chart, here is the data, and let's represent that data as a scatter chart. Here we have the number of students on the y-axis versus time on the x-axis. Okay, and we can see there is the data points that we had from the picture. If one clicks this data and then goes to series, right, you're looking for, there's a lot of options you can pick once you click the data. Okay, let's click the data again. Let's go back to customize, sorry. Click the data, sorry, and under here under series, and scroll down, you'll see that what we're looking for is this trend line. We're looking for the line that is trending that data, okay? Now this line that we click, you can see that it doesn't go exactly through all the data, but it comes close. It goes pretty close through 2 of the data points and tries to do what it can to come close to all the other data. Okay, one can then create a label of this, and you can use the equation on the chart, and there we have it. This is the line that says on average. We can see that we are losing, on average, we are losing 7.5 students per year. That's what the slope of this line is telling us. So even though 1 year we lost 12 students between the first 2 data points, and then next year we gained 5 students, on average this trend line is telling us that we seem to be losing about 7.5 students per year. And this is the equation of the line of best fit. It has a y-intercept of 15,170 and a slope of negative 7.5. Okay, so that is how you create a trend line using Google Sheets, and I will do another example in the next video.